be talking about scenarios, and in particular, a framework for scenarios called the SSP RCP framework. It's turned out to be jargon heavy and acronym heavy, so it's sort of fitting that there's just an acronym in the title without it actually being spelled out. What does that mean? But what this stands for is the Shared Socioeconomic Pathways, that's SSP, and the Representative Concentration Pathways, that's RCP. These are societal and climate futures, respectively. And this framework that it refers to is kind of the ways and approaches for integrating those two things to do interdisciplinary analysis in the future. And I'm going to talk about the status of this framework and the next steps. It's something that was set up over the past 10 years. Its roots go fairly far back, but it's really been in full working order for about the last, I would say, maybe six or seven. And let me start, of course, with just what it is, and in the simplest terms possible, how it works. And the idea is represented by this diagram, where you have a number of things situated on this outside circle, a number of elements that are pulled together, intended to be pulled together to do integrated interdisciplinary analysis and scenario development in the middle. Now, those things that get pulled together are the SSPs and RCPs, as we just talked about. SSPs, as I mentioned, are a set of alternative visions of how society globally in large world regions may evolve in the coming decades. The RCPs are greenhouse gas concentration pathways that are used with this orange arrow to produce climate model simulations of the future, so climate futures. These are sometimes combined with policy assumptions, and they are combined with integrated assessment model scenarios of emissions and land use and concentration. So there's all these elements that go into integrated scenarios. So this is a picture of the framework and how it's intended to be used. We often think about it's one thing I want to draw attention to. We often think about, oh, so what are the SSPs and what's in them, what's not in them, what can we learn from them? What we really want to be learning from is not the SSPs per se, but studies that have employed them, because they are an ingredient to integrated scenarios. They are not integrated scenarios themselves. And that's an important distinction that we'll talk more about. But let's, for a minute, go into a little bit more detail about what's in an SSP, and by extension in an integrated scenario that uses them. But the SSPs themselves have two components. They have some narrative text, a couple pages of text that tell a story about how the world may evolve, broad patterns of development, the logic of why certain elements are changing in some ways than the others. Why is population declining? Why is the economy perhaps growing especially fast? Why is technological change proceeding in a particular fashion? Relating this to social scientific theories about the way the world works. And then there are a set of quantitative elements that are consistent with those stories about, okay, well, if population is growing at a certain speed, what's the population size in every country over time? The same goes for quantification of levels of education, of urbanization, and of the size of economies. These are done at the country level for the world. And there's 5 of these SSPs, so 5 sets of quantitative elements, 5 narratives. For the sake of time, we won't go into details on exactly what the stories are in each of the 5, but hopefully these titles on the right give you some sense of their content. So these SSPs then are used as input, right, to create other elements of this framework. And one of those elements that, you know, we're all familiar with, pretty familiar with, is the integrated assessment model emission scenarios and land use scenarios that are then used to drive Earth system models. And so these narratives and the quantitative elements and potentially some assumptions about what kind of emissions reduction policies are taking place in the future, these all go into the models and what comes out of the integrated assessment models is these quantifications of emissions and land use change. And this figure I'm showing here is for CO2 emissions. The gray lines are all of the various scenarios that are just collected from the integrated assessment community in general, SSPs, not SSPs, just giving a sense of the range of scenarios that are out there, some with very low emissions, some with very high. The colored lines are a particular set of SSPs, 5 of them combined with a couple that include mitigation policies. And you see that they pretty well span the range of other scenarios that are in the literature. And if we look at these, and you can look at those same scenarios in terms of radiative forcing, just accounting for all of the other gases here. These colored scenarios are the ones that were chosen to drive Earth system models. And that was done most recently in the CMIP 6 exercise, producing a set of ensembles of climate model simulations for quite a number of the SSP RCP combinations. So how do we combine these things together, the climate model simulations and the socioeconomic simulations or socioeconomic futures? Well, I first want to talk about it kind of conceptually and then give an example or two. So conceptually, right, we want to combine these two things, a number of different forcing pathways or climate model outcomes. These are organized on the x-axis of this square space here. And what's being labeled is the radiative forcing level at the end of the century. Each one of those numbers stands for one of these forcing pathways and climate model outcomes. And then the columns in this space are the different SSPs. So we can combine these two things generally as a matrix of possibilities of possible combinations. Now, this is a little bit of a detail of distinguishing from the 4 RCPs that were in the CMIP 5 exercise. CMIP 6 ran all of those again, but added 3 more to create a set of 7. So each of these white boxes indicates a combination of a particular development pathway with a particular climate outcome. And you see that not all of the combinations have a white box here, and that is because it turned out that some of these weren't feasible combinations. So across the top row, the RCP 8.5, the high forcing scenario, not all of the SSPs, even when there's absolutely no emissions reduction in them, have storylines and quantifications of population and GDP and technological change and emissions and so on. When you do all of that, they don't add up to 8.5 watts per meter squared of warming. Only SSP 5 does in its unmitigated state. And so that's why there's only one box filled in. In some of these, because of or in the SSP 3 scenario in particular, because of the nature of that storyline, in particular that it's a non-cooperative story, without cooperation across countries, you can't reach the low levels of forcing. So there's no boxes down there. But otherwise, if you picked any individual box, like this one I'm highlighting here in green, what that would mean is that would represent sort of a container for all of the studies that investigated what would the world look like, what would impacts be, how much would mitigation cost, how effective would adaptation be if we were in a world that in societal terms evolved according to the SSP2 storyline, and in climate terms followed the 4.5 watt per meter squared forcing pathway. Now, keeping in mind that SSP2 can end up following many different forcing pathways. Why? Because of mitigation, right? You're at the top of that SSP2 column if you do no mitigation. If you do lots of mitigation, you get down to the 1.9 watt per meter squared forcing box, and the 4.5 is with some modest mitigation in between. So studies combine these the climate outcomes and SSP assumptions in an organized way, according to this matrix, to investigate how might outcomes differ if you have conditions or say two different futures in which climate is the same, say according to RCP 4.5, but one follows the SSP2 societal outcome, one follows the SSP3 societal outcome. You're going to have different impacts, different costs of mitigation, and so on. And so that's how you can use this matrix to facilitate work. The SSPs and RCPs have been used quite extensively. So up until about a year ago, there were over 2,000 papers in the literature that use the SSPs, and in many cases, although not all, use RCPs or climate assumptions based on them. And they're used in many different types of studies. The blue boxes here represent, the dark blue boxes represent impact studies. So you see that a little more than half of studies are actually of climate change impacts dominated by agriculture and water. A good number of them are on emissions and emissions reductions, energy, land use, kind of the driver's side. And then there are some others on regional outcomes, methods, and cross-cutting topics. So they're in wide use. They've also been extended beyond these sort of basic elements of narratives and 3 or 4 quantitative elements. Many people have developed additional sets of information consistent with the SSPs to allow them and others to do additional kinds of work. So there are now spatial population projections for all of the SSPs, not just at the national level, but gridded. There's income distributions, not just income growth at the national level, but the distribution of how many people are at lower levels of income versus higher levels of income across countries over time. Same thing for infrastructure, urban land, governance, and so on. There have also been regional versions of the SSPs developed, producing greater detail on the story of what's going on in Europe or at US subregions and so on. As an example, a study developed income distribution projections in order to look at what the implications of climate impacts for poverty were. This example was one done by a couple researchers at the World Bank that used assumptions about demographic change, about education, levels of education changing, and about shifts in employment by sector of the economy over time, particularly people moving from the agriculture sector into manufacturing and services, to look at how income distribution would change in the future when one also accounts for climate change impacts on agriculture and on health, which will also affect their income. This study drew a conclusion that we might end up with more than 100 million additional people being pushed into poverty by 2030 by climate change. The importance of the societal futures to this outcome is illustrated by showing a little bit more detail from that study. Each of these horizontal bars is a number of people that are driven into extreme poverty by climate change. And they're broken down. The top 2 are if we assume a relatively optimistic future societal development pathway. along with just a center, middle of the road climate outcome, right? This is only 2030, so there's not enough time for climate outcomes to diverge by scenario. So in this prosperity or fast economic growth SSP, the number of people driven into poverty is quite low. It's less than 20 million in either the high or low climate change impact scenario. In contrast, if you assume the world evolves according to SSP 4, which is a much more pessimistic scenario, totally separate from climate change, just things are not going well on the poverty front, in that world, climate really hits hard, and you can get, if impacts turn out to be high, over 100 million people in being pushed into poverty. So you see the importance of the SSP as an order of magnitude here for the outcome for impacts of climate on poverty. Okay, I'll stick with just that example because I want to be able to take a few minutes here at the end to talk about where things are going now, or where, let's say, where they need to go, and we'll see where they actually end up going. One is that there is a continuing need to further extend this framework. There's ongoing work on doing better extensions of income distribution, of looking at spatial information beyond population, but also of characteristics of the human population, like their education, their age, their income spatially, to understand spatial vulnerability and where hotspots of vulnerability may be. Also, a lot of push right now to try to connect this framework better to the biodiversity world. It has been used for biodiversity studies, but the connection has not been really strong. And this is really a kind of missed opportunity at the moment that we want to try to take advantage of and make a lot more progress there. It's actually been a while since the SSPs were created, and they are out of date in some respects, in some just base year values. GDPs are different. The outlook for the near term is different. And so with a lot of focus in the climate research world on what's going on over the next 10 or 20 years, it's really important that we update these. I think I'll skip the reference scenario one. More important is maybe thinking, we generated a set of scenarios in these 5 SSPs and lots of mitigation variants of them quite some time ago. Are there scenarios now that shouldn't be in there anymore? So for example, there's been some debate on whether the high scenario, the 8.5 watt per meter squared scenario, is too high. Is it no longer plausible that we could end up with emissions that high? Are there some that are missing? So for example, there's been lots of push in the advocacy community, for example, for a degrowth scenario. And there is no degrowth scenario in the SSPs right now. Is that a gap in our envisioning of the future? Another one I want to emphasize is that the SSPs and the RCPs, right, we can think of these as scenarios of inputs in a sense, right? As I said at the beginning, these are pathways that were developed. They're around the outside circle, right, of elements that we want to combine into integrated scenarios to see how does the world turn out. SSPs are not how the world turns out. They're how the world evolves in the absence of climate change and before we integrate it with the RCPs and the climate outcomes. Do we have community scenarios to share to say, what is an SSP 2 4.5, right? The world according to SSP 2 and 4.5. What does that world look like? We don't have a common understanding of what that is. We don't have scenarios of the outcomes. And so putting a bunch of effort into those to have a shared understanding of how the world looks like in an integrated sense, I think is a big gap at the moment. And last, I will mention that CMIP 6 is over, right? We've done all the climate model simulations for CMIP 6. CMIP 7 planning is now starting. And so we have to now think over the next 5, 6, 7 years, what kind of climate model simulations do we want to have? What kind of societal futures do we want to use to drive them as part of our CMIP7 exercise, whether that's producing climate futures with full Earth system models or with climate model emulation. So I will end there and turn it back over to Kevin.
Awesome. Thanks, Brian. So I hope that was a good